All right, guys, so you did a lab, and now you're going to have to do a lab report. And if you take a look at what the first page of the lab report says is sketch the equipment being used, please annotate the sketch, label the equipment and what is being measured, make sure that the dimensions and units being measured, make sure that the dimensions and units being measured match the instrument that is being used, all right? Now make sure that all the materials you are able to answer, make sure that for all the materials you're able to answer, how does measuring this material relate to the experiment? What instrument is best for measuring this material? Now, let's go ahead and see what I did here. I sketched what you did, right? The setup, the lab setup. You see there's iron, steel wool, but iron, right? There's a tube. Notice it's a sketch, not very accurate, it's not neat, doesn't have to be, just has to be intelligible. You have to be able to communicate that this is a tube in water, that there's pressure, there's air pressure with arrows. Notice I labeled everything. As long as everything's labeled, you'll be fine. And here you see the air pressure with arrows pushing out, because that's the direction the air is moving, right, as it hits the outside. And air pressure from inside the tube pushing down, right? So here we measured the height of the test tube, right? So we measured the height of the test tube from here to the top. And I actually kind of drew this incorrectly. It should be the bottom of the tube was flat. There was a reason I did that. I gave you a flat one so it could stand, but also so that it'd be easier to measure volume, and we'll talk about that in a second. So that leads us to the setup. So there's your setup. Now notice that we haven't I haven't wrote this or discussed the units yet, or how to measure. We just noticed that we measured height. And so what we'd want to do is we'd probably want to, let's start here first. We'd probably want to mention that the height, we used a ruler to measure height. And that the height was measured in centimeters, right? So that seems simple enough. Now, what were we going to have to calculate or measure if we were going to actually measure how much gas was used, how much oxygen, what percent of the air was oxygen inside the tube, or what percent of the air in our atmosphere is on average oxygen, right? So those are the two questions. Really, how do we get there? How do we get from measuring, putting a little mark on a tube and then putting another mark on the tube and then measuring that percent volume? So if we measured how far it moved, so from here, from the beginning here to the end here, then we would use a ruler. Okay, well, that's fair. But that doesn't get us what we want. It doesn't get us the volume of gas. So the real question then is, how could we calculate and measure the volume of the oxygen removed, the oxygen gas removed in the experiment, right? Because remember, the iron and the oxygen bond reacted, and that you took the oxygen out of the air that was in the tube. You took the oxygen out, and because of that, the air pressure lessened, and the water rose up, and you saw the picture of the actual experiment in that in the last video, that the water level went from here, all right, from this line here to this line here. So how do we measure, how do we come up with a number, a percentage of how much of this was actually changed, or what percentage of this was oxygen? Because the part that's missing, the part that left, is the percent oxygen. So you can eyeball it and just say, well, what percentage is it? If this is from here to here is the whole thing, and this was the change, well, what percentage of the change was this? So you could use a ruler. You could use a ruler and measure from here to the end, and then measure from here to the end, and see what percentage of this space was this missing portion, right? So let me highlight it. What percentage of the what percentage of the tube, the missing gas, was the missing gas, right? Or the yellow, what's highlighted in yellow here, right? Well, you could use that ruler and you could go ahead and do that. Or you could do it two other ways as well. So how could you measure volume? If you measured volume, which the data table that I'm going to give you for this experiment actually does measure volume, and we measure the volume before and then after. So how do you measure the volume then in this tube before, so from here to here, and then after from here to here, right? The volume before and after the chemical reaction. So there's two ways to do it. You could use volume equals pi r squared times height. So remember that whenever you have a circle, and this reaction vessel was a cylinder, you have a radius. That radius, right, times the height. So if you laid the tube on this, if you laid the tube down, you'd see that there's a radius. This part here has a radius, and that radius times pi times the height, which is the distance from here to wherever line you have. There were two lines. There's one line here, right? And then there was another line where it began, and another line here where it ended. So you'd measure those two heights, calculate those two volumes, and you'd be at your volume initial and your volume after, right? Or final. Your initial volume and your final volume, and then you could calculate the difference, and that would be how much oxygen actually left the test tube because it reacted with the iron. Okay? So that you could do that. That's more than reasonable. So you can take a look at just measure with a ruler and look at the difference before and after. You can measure the volume. You can calculate the volume before and then after. Or you could use a third method. And the third method is probably the most, probably the method that would make the most sense when it comes to, it's the most intuitive, right? So if you had a volume, if you had two marks, you had a mark here where it began. Now it's upside down. Now we're going to flip it, right? So this is the bottom now. Your bottom is down here. And so you take that, you would take that that test tube and flip it, and so this is where you began, and then this is where you ended. So how could you measure the volume? Well, you could fill it up with water, right? First fill it up with water at the lowest end here. Then pour that water out. Take that and pour that water out into what's called a graduated cylinder. So a graduated cylinder is another cylinder just like your tube, except it has little graduations, little measurements in milliliters. All right? So each one of these could be a milliliter. So if your tube then held, this much water, then you could say that it was, 30 milliliters to begin with. At the end, rather, because it stopped here at the red. Remember, this is where it ended, and then if you fill it up all the way to its maximum, right, to the beginning, and you do it again into another graduated cylinder, or the same one after you've emptied it, then there you're going to have more, obviously, because the line's higher. Then you have, again, you're measuring in milliliters. Maybe you have, 40 milliliters. I don't know. I was just making the numbers up. So you started with 30, you ended up with, you started with 40, you ended up with 30, so you lost 10. Then you can calculate your percentage from that. So there's these 3 or 4 different ways here, right? One, you can measure using the ruler and look at the differences between them. 2, you could use, you can measure the radius and the height of the 2 different lines. Still, you need a ruler here. So what instrument would you use here for method 1? You would use a ruler again, and you'd measure in centimeters. And by the way, if you think about it, what centimeters would you get? I don't know if you know, some of you may not realize this, but if you took and measure the radius is going to be in centimeters, right? So let's say the radius is 1 centimeter. So that's centimeter. And then you're going to multiply, you're going to square that, so that's centimeters squared. And then you're going to multiply it times centimeters. So that's going to equal centimeters cubed. So now centimeters cubed, you see, now this is key, so let me be clear on this. A centimeter cubed is a milliliter. So let's go ahead and take some notes here. Let's go ahead and summarize these things and use Cornell notes the way it's supposed to be used. So a centimeter cubed is equal to 1 milliliter. So they're the same. So on this end, method 1, I'm going to end up with centimeters cubed, and that's a millimeter. By the way, if you ever watch a hospital show, that's why they use cc's, centimeters cubed, okay? Cc's are milliliters. Now here in the graduated cylinder, you're using milliliters, all right? So here in method 1, let's say we use a ruler, and a ruler is going to be, we're going to use the units centimeters. In method 2, we calculated volume, and volume is in milliliters. And let's remember the centimeters cubed is a milliliter. So there's a lot of math there. I don't think it's incredibly difficult, but it's a lot to think about. And that's why lab reports are so important, because they help you process all this information from this simple little lab of how much oxygen, what percent oxygen was removed or is the air composed of. So by removing that, using the idea of air pressure, measuring the distance between where the water began and where the water ended, looking at that, you'd get a percent, right? So how do we figure out percents? What's a percent? A percent is whatever it is you have. So let's use the variable x divided by 100, whatever 100% is, right? So if it's whatever, I shouldn't say what 100, let's say the total, all right? So if the total, let's say the total here, the beginning, or the total was 40, and you ended up using 10 milliliters, right? So it'd be 40 divided by, you ended up you used up 10 milliliters of oxygen. Then you would say 10 milliliters divided by 40 milliliters, because 40 was the total, 10 was what was used up, and you'd multiply that times 100, times 100%, and that would give you your percent total. So whatever 10 divided by 40 is times 100, it would give you that percent. So if that was the case, then what you would get is 25%. So in this example, this was an example of how you would use percentages. So that's my percentages. These are my units. So let's try to make sure and see if we can. So you know that volume is measured in milliliters, that rulers measure centimeters, that percentage is the total whatever your sample is divided by the total, right? You know that that you have to multiply that times 100% to get your percent, whatever it is. All right. So by the way, you could do that. You can do that down here if you look and see where did I get that 40 and 20. Here's 40 and 30. So in this example is 40 and 30. So can you figure out what percentage of 40 is 30? If you ended up, in this example, you ended up with 30, you started with 40, so your total was 40, but you used up 10, right? The difference between 40 and 30 is 10. So you used up 10, so you'd get 10 milliliters divided by 40 milliliters. So 30 is what you're left with, 40 is what you started with, but you have to subtract 40 from 30, and that 10 is what you used up. And that's where you got that 25%. So that's how you would work the percent atmosphere, and those are your units and your tools that you would use to measure, which were the questions that you saw in your lab report here. What instrument am I using for measurement? What does measuring this help me to, how does this help me measure or answer the question? And do I expect the measurements to go up or down? Well, I expected the volume to go down, the volume of gas to go down, because I expected the water level to go up, right? I expected this water level to go up, so the volume of gas to go down. So you see the water as the water level went up, remember this is now the bottom, I flipped it over, as the water level started from here, ended up here, that is a loss of gas, but the water went up in the column inside the test tube. All right, so if you did the lab and you paid attention and you look at this, that's the first page of your lab report.